So how mining works? So we have block timestamp, we have block index, block timestamp, we have nonce value. So this nonce value can be modified by any miner, so no issues. And it should be modified actually to reach the target value. And this is original data, so transactions data. As previous. Hope are you able to hear me?
Yeah, I can hear.
Okay. Hope you understand the transaction model of Bitcoin. So, which is similar in even what we call Ethereum also.
Rao, a couple of questions. One question is to reach the target, we have a combination of values. So one is a previous hash value. So if I am having a node, will I know what is the previous hash value, or the whatever the server setup that is there, it knows, and then it will be framing that target?
Yeah. So in network, all the nodes knows about the current hash code, current block hash code.
Okay.
So that we'll call it as previous block hash value. So entire network understands what is the current block hash code, and this block hash code should be set up, added up into the new block actually. So this block, I think it is 938, right? So this 938 hash code is, I think, 772 block number hash code.
So Harish, it is a peer-to-peer network, so the whole database is stored in every single.
So this block 772, the hash code it is 938. Right?
Yeah.
So what your point is, how this hash code will be known to all the nodes in the network, right?
Yes, yes.
Yeah. So here in blockchain ledger, all these data will be stored. Right. So this is, anyone can see the data. So that's not a problem. This hash code anyone can see. The current block hash code can anyone see. There are no restrictions. Hope you understand.
Yeah. And other thing is, so so when this cryptocurrency is started in last year, so people started talking that the technology used for Ethereum is more powerful than Bitcoin.
Yeah.
Like that. So the way of validating is different in each cryptocurrency.
Yeah. So almost all these public blockchain network applications, it is transaction mode is more or less same. But maybe in Ethereum, that block creation time is 14 seconds. So let me open. Yeah, it's already there, right? So in Ethereum, it may not take 10 minutes time, but the fundamental concepts, whatever we talked, it remains same. Whatever cryptography, shared ledger, peer-to-peer network, mining, consensus, smart contracts, all these are all there in Ethereum as well. But the transaction model, it may take less time. Okay, so if it is, there are some downsides in Bitcoin. So Bitcoin is dedicated for only that particular application, right? But Ethereum, it has Ethereum crypto as well as Ethereum framework actually. So some applications, 10 minutes is huge time. To create the transaction, if it takes 10 minutes time, it is a huge time. See, I will give two comparisons. So in stock markets, when we compare with the current, as I'm not sure about US, so especially in India, the transaction time plus 2 days, it is total 3 days time it is taking to get the real ownership. That means To complete the transaction, it is taking 3 days time at present. So now if we improve the transaction time about 3 days to 10 minutes, so then it is a huge change actually. But in current banking system, the transactions are almost instant, right? Within seconds, we are getting transaction confirmation. So which may not be best suited this Bitcoin or Ethereum for the banking applications. Why? Because here we have two things. Number one is latency and throughput. So always latency for performance wise, latency should be low, throughput should be high. So we'll take separate class on this. So generally the latency for Bitcoin, that means TPS, transaction per second. So transaction per second in Bitcoin, it is, you can just divide 3,000 transactions, 10 minutes by 3,000 by 10 minutes. So 10 into 60 into 60. Maybe for every 1 minute, for every 1 second, there may be 1 or 2 transactions or 4 transactions, right? Whereas the TPS, when we compare with Visa or MasterCard network, so it is about 30,000, I think. 30,000 TPS is there. So per second, there are 30,000 transactions are performed on Visa network. Why? Because this is a global network. Even we'll talk about PayPal also. So for applications like Visa and MasterCard, Bitcoin transactions, it is not best suited. Why? Because this is high TPS actually, right? So I think this is throughput. Yeah. So in terms of TPS, Bitcoin, it is Bitcoin transaction model which is not supported for this. But Bitcoin purposefully they are doing for this. Why? Because 6.5 minutes difficulty we should maintain. Why? Because we should prevent the hacker attacks actually. That is the main thing. So majority of the miners, they will filter it out at target, reach the target value. So in the racing itself, to solve the puzzle itself, many of the miners will be filtered out. So if we want to face any interviews, maybe if it is high demand, more applications are there. So companies, what they will do, they will put more high filtration things, like group discussions, tests and all before real interview. Hope you understand. And concepts remain same. Maybe the time is different. So in Ethereum, to create the block, it will take usually 14 seconds. Maybe here block size is very less. So for each block, it has only about 100 transactions to 200 transactions. So this is the latest block, right? So about 177 transactions happened in Ethereum. Okay, it is completely on their application architecture, but overall things what we can understand, the concepts actually. Okay, so if we apply this Bitcoin transaction model in current Indian stock markets, so 10 minutes transaction time for the transaction confirmation, it is a huge benefit actually when we compare with current 2 to 3 days time. But Bitcoin, which is not best suited for the banking transactions. So in banking, we require more number of transactions, and the use case is also different. So that is for private blockchain, and this is for public blockchain. So here anyone can do the transactions, but in banking, there should be a rules, right? So we need to fill up the KYC and all, we need to open the accounts. So then only it will be followed. Is that fine, Harish? Yeah, Nataraj, you are asking about difference between public and private blockchain networks, right?
Yes. Yeah.
So you want the difference, or you want to understand the use cases?
Yeah, I think the use cases would be good.
Yeah. So there is a site called CoinMarketCap. So here, worldwide, whatever cryptocurrencies are there, we can able to see the market cap and the current price, everything. So there are two things in cryptocurrencies: number one, coins, and number two, tokens. So these two, we can call it as cryptocurrencies only. So generally, coins has their own software or their own platform. Tokens, they doesn't have the platform. Tokens should be depend on some frameworks. So if you observe top 100 coins, that's why Bitcoin. So Bitcoin has their own framework. Ethereum has their own framework. XRP, Ripple has their own framework. Bitcoin Cash has their own framework. So all these coins has their own framework. Whereas in tokens, if you observe top 100 tokens, these tokens, both are applications only, but these tokens are dependent on some other frameworks actually. So in top 100 list, if you observe, majority of the tokens were built on top of Ethereum framework. Okay, so all these cryptocurrencies are best examples for the public blockchain network applications. So already we talked about what is public blockchain and what is private blockchain, and mixing up or hybrid blockchain or consortium. And two more things: permissioned and permissionless. So in public blockchain network applications, any user can perform the transactions. So in terms of accessing the network, there are no restrictions, right? If you want to buy the Bitcoin, you need not to log in the system and do. If you have that address of your wallet, you can use that wallet and you can do the transaction. Tomorrow, if you give your wallet to some other person, and they can also do it. You need not to log in the system and you need not to do any kind of transactions. Whereas in banks, so you need to first authenticate it and you need to prove that you are the authorized person, and then only you can able to do the transactions. So this public and private blockchain network applications only in terms of retail users accessibility. Whereas permissioned means it is in terms of network, it is in terms of infrastructure. So infrastructure means nodes only, right? So that nodes has that computational power and all. So in permissioned, so this is talking about the infrastructure, and this should be controlled by the organization. So the nodes, whatever is there in the blockchain network, it will be controlled by that particular network only. So all these use cases, whatever we talked in previous session, it is best suited for the private blockchain network applications. Maybe another slide. So cryptocurrencies are the best use cases for the public and permissionless blockchain network applications. Whereas bank transactions, digital health records, digital education certificates, so all these will be best suited for the private blockchain network applications, right? So anyone cannot join as a miners or nodes in the network in private blockchain network applications. In public blockchain, there are no restrictions. Anyone can join as a miner and they can do the consumption of their resources and they can participate in the transaction models as well. So all these supply chain, control of fake drugs, land registrations, vehicle registrations, all these will be controlled by someone. So there is a discussion actually, this private blockchain network applications are not pure blockchain network applications. There is big discussion is going on. So that's why majority of these technologies, though they are calling as blockchain, there is a big difference between DLT and blockchain. This DLT is called as distributed ledger technology. So all blockchain applications are DLTs, but not all DLTs are blockchains. Okay, so strictly, frankly speaking, so Fabric, Corda, Sawtooth, these are all DLTs only. Whereas Bitcoin, Ethereum, these are all pure blockchains. But in general, we'll call it as all are blockchain technology. But there is a slight difference between DLT and blockchain. I will take a separate session on this. What exactly DLT and when we will call it as DLT and when we will call it as a blockchain. So you understand the minute difference. So generally, blockchain applications like Bitcoin and Ethereum, these are all decentralized applications, not centralized actually. That means no one controls that application. Whereas the banking applications and digital health records from any hospitals, these will be, looks like it will be controlled by some central authority, right? So though we have central authority, we are applying that blockchain concepts like consensus, immutability, digital ledger and digital immutable ledgers. So immutable means definitely no one can modify or delete the data. Once the data is recorded on the blockchain ledger, no one can touch the data. So if anyone is touching the data, then definitely that is not a blockchain use case. So this I will explain in later sessions. So what exactly, which application we'll call it as DLT and which one we'll call it as blockchain. But at least at this point of time, you need not to go more in depth about this one. Think that all these are frameworks which are part of blockchain. Okay, so all these use cases are best suited for the private blockchain network applications, except the first one. So the first one, it is for public blockchain network applications. So tomorrow there may be a use case. Suppose if any state government comes up with that electricity meter readings. So now in electricity meter readings, so somewhere in the summertime in India, May we got about 8,000 rupees per month that electricity bill, and in June it was about 4,000 or 5,000. There was a huge difference actually. 50% comes down. So in May it was 8,000 and in June it was around 4,000, 5,000. So, but the consumption generally in May and June almost are same, right? Because of summer. But there was an error actually in the electricity meter readings by the persons who comes and visit the houses, right? I think they didn't maintain the exact record. So there were some problems actually. If they don't take proper reading, so the slab rates will be changed. So that's why it will be end up high, this one, electricity bill in some 1 month and the next. So these type of issues we can resolve using blockchain. So tomorrow, all the household electricity meters will be linked up with the IoTs, what we call terminal or IoT-based systems or sensor data. And if we add up the database as blockchain, so all the transactions for every 1 hour, if the transactions are recorded by the sensor of the IoT on blockchain, so these type of wrong entries and all we can resolve, right? So maybe it is maybe we can apply this as a public blockchain network application. Though if it is a public blockchain network application, we are not disclosing the identity. So can we understand who made this transaction? Definitely you cannot understand who made this transaction, right? So in last session we talked about this transactions. So this transaction, who made? So here we are not revealing the identity. So he is the maybe buyer or he is the seller. So here identity is hidden. So definitely these type of applications or these type of concepts we may put it in that electricity application as well. So there you need not to maintain private blockchain network application. It is just a household electricity reading. So though it is a transparent data, so we can hiding the individual identities, right? So all will be in hash code. All these addresses will be in hash code. Definitely with this address, definitely no one can find this one. So just you imagine the two things, privacy and transparency. So if you want privacy, better go for private blockchain. It is completely dependent on the business requirements. So if you want more transparency, you can go with public blockchain. But in private blockchain, mining is not required. Majority of the cases in private blockchains, mining is not required, but consensus must. Why consensus must? Even in private blockchain network applications also, the decision will be taken by the computers only. So there it is not a single server, it will be multiple servers and the decision should be made by the machines. So like PNB scam, it will be prevented by the machines. So if the decision comes from single machine, definitely database administrators or someone can modify the data. So instead of one server, if we put multiple servers and all these servers data, if it is not controlled by a particular database administrator, and if it is a blockchain ledger, definitely you can prevent that double entry issues. Okay, in the indirectly in PNB case, it was happened double entry. Nirav Modi has about 1,000 crores worth of assets. Maybe they have given 10 times more credit notes. So that is the best use case for the double entry. So double spending. So in digital world, there may be a high chance for the double spending. That's why blockchain is going to control or prevent that double entry. So consensus also playing a major role. Why? Because all parties or all participants are in distrusted only. So definitely we cannot trust, each machine cannot trust other machines' data. So that's why we need group of computers, and all these computers will collective decision, whatever it will take, that will be finalized. Hope you understand, Mr. Nataraj, about private and public blockchain network applications. So it is completely dependent on the architecture and also the management, how they are going to create the applications. Is it more transparency, or is it more privacy, or is it more public involvement, or is it only private people involvement? So it is all our architecture related issues. But currently There are beautiful frameworks to build private blockchain network applications, Fabric, Corda, and Sawtooth. If you talk about strictly, these are all not pure blockchain network, it is DLT, distributed ledger technologies. Only Bitcoin and Ethereum, these are the best for the pure blockchain network frameworks. If you have any doubts, you can proceed. Maybe two new persons joined, I think Ramesh and one more. Ramesh, can I know about you? So currently what you are working on and what
Hey, this is Ramesh. I work for Natraj.
Oh, okay,
so
okay.
I'm in the same team.
Yeah. Okay, okay, fine. So for this course, I think Natraj has explained. So actually, for this course, it is mainly for writing smart contracts. One thing, it is understanding blockchain basics. Second one is blockchain internal things, how the transaction model will be happen, and all the basic features. So how we can improve the trust and how we can improve the security, and also how we can cut down the cost of the business operations, and also how we can reduce the risk in the businesses, transparency, privacy. So all these things, how we can achieve, at least we need to understand theoretically, then we need to understand the architecture of the blockchain. So maybe Fabric architecture is different, Corda architecture is different, Sawtooth architecture is different, Bitcoin architecture is different, Ethereum architecture is different. Though all are having similar technology, all are having all these concepts, cryptography, ledger, peer-to-peer network, consensus, mining, all these are all having, since though all are having same concept, but the model is different actually when we compare with the frameworks. And also we need to understand which framework is best suited for which business requirements. So Ethereum is for what? And we need to understand what is the architecture of Ethereum, how the data will be stored in Ethereum. So what is Ledger? So there is a minute difference in terms of data storage and transaction model also in Bitcoin and Ethereum. So in next session, I will explain what is the difference. What is the difference of the transaction models in Bitcoin and Ethereum. Okay, and also the main intention for this course is application development. So it is for blockchain application development. So majorly we need to build smart contracts, and how we build smart contracts and how we compile and how we deploy these smart contracts on blockchain environment, and also how we can execute these smart contracts on the blockchain runtime environment. So this is the main intention of the course, and at the end of this course, we need to integrate the back end blockchain applications with the front end. So all these dApps, decentralized applications, how we can integrate with either mobile application or web application. So at the end, we need to give that flexibility to the customers. So we need to hide all the complexities. So at the end user, they should feel comfort, like whatever we have given provision with the web applications and mobile applications. And they need to enter the data from the web application and mobile application. But in the back end, we need to improve the more security, more trust, more what we call privacy. So these kind of things, how we can improve in the back end. So maybe in future, how all these business people, the minimum requirement for any business, it is business website, right? So without website, I think nowadays definitely it is very difficult to run the businesses. So maybe in future, the minimum mandate thing for all the businesses is blockchain. Maybe there may be a situations arise. Maybe all businesses, they may advertise that we are running our business on blockchain technology. So maybe we'll see those days may come. So maybe somewhere in 2001 and 2005 times, having website for a business, it is like not a mandate. Maybe after 2008-9, slowly entire world think that every business needs a website. Like that, maybe next 5 years, 10 years down the line, all businesses definitely they may need actually to survive in their businesses. They may need to advertise or to shift their business on blockchain. So many trust related issues. If we observe, many businesses are having trust related, whether it is food or whether it is hospital treatment or whether it is any service. We are thinking about trust. If you want to transfer some funds from US to India, what 3 things you will get immediately? First, you will think how safe it is, whether these funds will be safely transferred. Next, how quickly it will be reached to the destination. And what is the transaction cost? Right. So these 3 things everyone can think, right? So whether this fund will reach safely or not, whether this fund, how quickly it will reach, and what is the transaction cost. So with blockchain, definitely you can improve the safety or trust, and also you can make almost all instant transactions, also with the less transaction cost when we compare with current transaction costs for the remittances or cross-border transactions. So these kind of applications definitely we can see, and also the main thing it is we can internally we are improving the communication among machine to machines, right? So we are minimizing the human interaction and we are improving the thing. Not only banking or cross-border transactions, even insurance claims, even supply chains. So all these required actually. This technology will be adapted by many industries. You believe or not, by end of 2020, I think Dubai is targeting or aiming that all government-related whatever schemes or operations will be moved on to blockchain technology. Whatever passports, data, all public-related data will be completely moved on to blockchain. So why they are moving? So definitely wherever there is limited trust or no trust, the areas wherever there is no safety for the data, for the applications, so those areas completely will be filled up by the blockchain technology, right? So there are some downsides even in this blockchain in terms of latency and throughput. In next session, I will explain. So in terms of that one, still few more technologies are going to add up to the blockchain, and it will be improve all these efficient throughputs and latency issues actually. Okay. Yeah, we have another 6 minutes time. Yeah.
But just, forgive
No
my
problem.
kindness. Just basic questions, right? So, when we talk about this blocks and there's all these transactions, right? I was curious. Is there a particular database you store these transactions in all
Exactly.
these
Yeah.
systems? So, what kind of databases will that be? And for the reporting purposes and all these things, how that can be used would be a question.
Yeah,
And
very
second
good
would be when
question
we talk
actually.
about your security, right?
Yeah.
So you said that it's practically non-hackable. So, but with AI and all these things coming up, and the DoDs, you can still attack those these servers with all those. And when we talk about non-hackable or the transaction being the safest, all we are saying that is because we have. So, for example, if there are 35,000 servers,
Yeah.
a transaction set in all 35,000, it is practically impossible to hack all of them at one time.
Yeah.
But then, is that the rationale behind saying that it is practically unhackable, or is there any other particular reason for that, for saying that?
Yeah. So the attack name is correct. Whatever I mentioned, DoDs are not
Yeah,
sure about
data
this attack.
service.
Yeah.
Yeah.
So because of this attack, well, I think the attack it is in layman point of view, If many number of requests comes onto the system, I think this attack is possible. If more number of requests hit onto the system at a time, so maybe this is possible. That's why they mandate it for 6.5 minutes in Bitcoin actually. So, and togetherness of mining and consensus, that's why they are providing high security for the network in terms of creation of the data and in terms of validating the data.
No, my point was basically, even if you give 6 minutes time, right? If you're bombarding the network entirely for the whole 6 minutes or 10 minutes, whatever may be, your transactions or your communications will be entirely blocked for that whole point of time. So there will be no commits at all.
So that's why it is 10 minutes time, right? Now, for initially, all the transactions will be recorded on the memory pool or transaction pool. And from there, they are picking up the random transactions and they are setting up one by one. So that's why we need 10 minutes time. So whatever transactions hit it up, everything will be recorded on the transaction pool only. Hope you understand.
Maybe. I'll understand a little later because
kind of so suppose if anyone attacks hugely on transaction pool, right? All will be rolled back. There is no use, right? Once you record the transaction on the blockchain ledger, then only it will be final confirmation.
Okay.
So whatever happened, it will be unconfirmed transactions only on the memory pool. So this is unconfirmed transaction.
So in that case, can the transactions all stay untransactional if there is a huge attack?
Yeah, no issues. Even if it happened, no issues. There is no use for the hackers.
Okay.
So when the confirmation will be done after mining and consensus happen, then only the block will be added up onto the blockchain. Until if any hacker attacked before that confirmed transaction, there is no use, right? So all money will be not transacted. That transaction will not be performed. Suppose if I transferred $100 to you or 100 Bitcoins to you. So if any hacker attack happened, so no use, right? My 100 will be there at my place. It will not be moved onto your account until the block will be created.
Sure. No, this may not be a valid question at all, but I was just out of curiosity. I was trying to ask you. Because you could be entire network for a couple of hours and a lot of transactions which will never be committed at all. So there will be disruption, right? So that is where I was going through this. So anyway, thank you.
Ramesh, actually we have only 1 minute time. Definitely we will discuss about this. I like this attack, DODS attack. So we'll definitely discuss. We have only 1 minute time. The first question what you asked, I forgot actually.
About the reporting and all those things.
How so the database part you are asking, right? So there are level data, the NoSQL databases. So I will take more in depth in next session about NoSQL database and how the data will be stored. So this NoSQL database like LevelDB, CouchDB, MongoDB, these databases are blockchain databases. So in Ethereum, we are using LevelDB. And we can able to get the data back and we can go with the analytics purpose also. So in next session, I will try to explain the databases. Okay. So LevelDB, CouchDB, MongoDB, these are the NoSQL databases for the blockchains, edges. Can we rejoin or can we close the session? It is less than 1 minute.
We can close this.